upper and lower bounds. So this is the reverse of rounding. This is saying after it has been rounded, the weight of this sack of potatoes is 9 kilograms. What's the smallest and the biggest it could have been before it was rounded? So if I know it's been rounded to the nearest kilogram, imagine a ruler that's marked out only in kilograms. So it would offer you the choices of 8 or 9 or 10 because it's only marked to the nearest whole kilogram. Where would you have stopped rounding to the 8 and started rounding up to the 9? Well, it's here. 8.5. Where would you have stopped rounding to the 9 and started rounding up to the 10? Well, it's here at 9.5. Okay. Now, I know that 9.5 would round up. But it's understood when you're doing these questions that you go to the first one where it would round the other way rather than the last one. So 8.5 and 9.5 are called the bounds of this value, the upper bound and the lower bound. So the same kind of a question, except this time instead of telling me it's been rounded to the nearest whole number of kilograms, this time it's been rounded to the nearest one decimal point, one decimal place. So I imagine my ruler again marked out showing me what the options were to one decimal place. So it could have rounded to 1.1 or 1.2 or 1.3, but in this case we know that it rounded to 1.2. Where would it have started rounding to 1.2? Where would it have swapped from 1.1, 1.2 here? 1.15, and it would have started rounding the other way, would have started rounding up to 1.3 here at 1.25. So to show this on a number line, here's my number line with the numbers shown, and I would just draw across here. And there's a slight technicality here. I would draw a filled in blob to show that I'm allowing 1.15, because if it was exactly 1.15 it would round up. I'm leaving an open blob to show that if it was exactly 1.25 it would round away from 1.2. But 1.25 is still the upper bound. Don't get confused and start writing 1.24 or 1.249. The upper bound is where it swaps. So the next style of question, similar technique. So the field's width is 35 meters to the nearest whole number of meters. So here's my imaginary ruler, and I know that it's 35 meters to the nearest whole number. So the smallest it could have been would have been 34.5. The upper bound would have been 35.5. So I know that this length here is somewhere between 34.5 inclusive to 35.5 exclusive. In other words, it can get as close as it likes to that, but never quite be equal to it. The length of the field is 47 to the nearest whole number. So here's my imaginary ruler marked out in whole numbers. So the lower bound would be 46.5, upper bound would have been 47.5. So the length of this field is somewhere between 46.5 through to 47.5. So that's the upper and lower bounds for the length and width. And the final question, what's the biggest possible area? Well, the biggest possible area is going to come from if I've got a field which is as wide as possible and as long as possible. So it would be 35.5 times by 47.5, which would give me an answer of 1686.25. And obviously if the question had been changed and asked me for the smallest possible area, that would come from the smallest possible width times by the smallest possible length.